Okay, go ahead.
Hi, I'm Miran Branish, and I'm from Project Iris, and I'm on kwartzlab TV. This is Alex Spetra over here, and this is Alex Roman. And basically what we did here, we built a capsule that's going to go to about 36 kilometers on a hydrogen balloon. I mostly focused on the physical design and the antenna design. So here we had a custom capsule made of extruded polystyrene, as you can see. It's clad in mylar to insulate it from the extreme cold temperatures up there. We've integrated a parabolic reflector antenna here to boost the gain on our dipole, so we can actually send pictures live to the ground as it's flying up all the way to its maximum height. Alex can talk about some of the hardware we custom designed here.
Sure. What we did here is that we built a custom printed circuit board that sits on top of an already existing embedded microcontroller. Our custom board houses our specific peripherals, such as the Extend 900 MHz long-range communications modem, Trimble Copernicus GPS, digital compass, 3-axis accelerometer, barometric pressure sensor, and a GSM module for sending text messages and things like that. All of this board is built using surface mount components, and it was custom designed by us and manufactured at a professional manufacturing facility. And I think Alex is going to talk about the software a bit.
Sure. So I'll tell you a little bit about the software for this. What we actually have, we have two main components. One is actually running on the board here in flight, and the other side is running on the ground. And we actually have our own communication protocol that we designed. And what we're actually able to do is we're able to send telemetry, video, and images from the capsule back to the Earth in real time. So up here on the capsule, we're actually running Windows CE6 as the main operating system. We have basically a very concurrent software architecture that's communicating with all the sensors, it's logging data, it's accepting commands from the ground, and it's constantly transmitting back to the Earth. And on the ground side, we actually have a ground control program, which actually tells us not only where the capsule is, it not only allows us to send commands, but we can also figure out where it's flying, where we need to point the antenna, where we need to drive in order to follow it as it's flying across Ontario.
Awesome. So in 20 words, this is a camera on a balloon capsule that's going up to 88,000 feet?
120,000.
120,000 feet?
Yeah.
Okay, that's awesome. And then you will recover it and get pictures and dazzle the world.
Right. It sends us a text message when it lands telling us where to pick it up.
Oh, fantastic. Okay, so questions from the audience. Shout your questions out. Real loud.
How much memory is on the camera?
4 gigabyte SD card.
It sends the live images from the camera directly to your base?
Yeah, thumbnails actually.
Yeah, it downsamples it to about 300 by something.
No, it's customized, but
yeah, but that's
small thumbnails that can be transmitted over 9600 baud, which is what we have from the extended modems.
So when are you guys launching?
3 weeks.
3 weeks?
Right after exams.
After our last ever exams.
Go.
How does it send you text messages?
It actually, we have a cell phone module, which is sitting right here, and cell antenna is sitting right back there. So as soon as this thing descends below 5,000 feet, it starts to try and acquire a connection with the Rogers cell network. And then as soon as it connects, it will get its information from the GPS module to find out its exact positions, and then contact us and let us know where it is.
Do you guys anticipate any problem with the last 100 meters of finding this thing? What's your resolution on GPS?
Actually, the GPS is really high resolution. When we were testing it, we got up to half a meter on it.
Oh, sweet.
So it's very, very
to aid us, we have these beacons.
You can turn one on.
Yeah, we can turn one on.
There you go. So at least in the dark, they're kind of easy to see.
Fantastic. And there's a parachute involved here, as well?
Yeah, we didn't bring it. It's
okay.
a 4-foot chute. It's a professional chute we got from this guy in Texas called the Rocket Man.
Okay.
He's the first ever guy to build a chute that can stop a Mach 1 model rocket or something like that.
He's apparently the only guy to ever build any civilian rocket that exceeds 3 a second. So how awesome is that?
All right.
How much does that thing weigh?
2 kilograms.
2.2 kilograms.
That's pretty light.
I guess it'd have to be based on the volume. You guys have some restrictions on the volume of hydrogen you can use to lift this, yeah?
We have to use, the maximum size is 1,500 gram balloon, which can hold about 3 cubic meters of hydrogen. So that's our restriction without violating any laws. And so we have to keep this under, about 2 kilograms because we get 4 kilograms of free lift. So we need the 1.8 or so to get it up there quick enough.
Could you modify it to go to space?
No, the really hard thing is it's pretty easy actually to get up to that level of the atmosphere, but to break, to basically get escape velocity, right? To break the force of Earth's gravity, right? You need an incredible amount of energy.
Or if you're talking just
And the balloon will expand too
Yeah.
much.
Well, yeah, your balloons top out at 120,000. Or like, I mean, you can fill it with more stuff, but then you have to get a bigger balloon, and you know, it can only go so high.
Now, there's also like special balloons made out of plastic materials that do not actually expand, right? But those are much more expensive and much harder to come by.
But those still won't get you up high.
How hard was it to get your hands on the compressed hydrogen to fill the balloon?
Actually, it was pretty simple. It was simple because we are at a university, so we just went to the chem stores and asked for a tank of hydrogen. They had one on hand.
Are you worried about possibly blowing yourselves up?
Actually, the hydrogen is hydrogen is not flammable below a certain concentration of air. So as long as you keep the air below 4% of the total volume, you can actually ignite the hydrogen. We also have a pretty. It's not like a. It's a pretty robust rig that we're using to fill it. So you know, we're minimizing the risk there as well.
Yeah,
There's no leaks or anything.
Yeah, we're using proper regulators, proper hoses. You know, we got trained in use of hydrogen gas cylinders. So as long as you work with hydrogen safely, it's actually pretty easy.
But you can use helium as well. I mean, you get less lift. You'll probably go to the same altitude though, just more drift. So if it's a calmer day, you could choose to use helium as well. Interchangeable.
Could you launch it with a rocket? You have to get enough thrust, and you have to shield it from the friction of the atmosphere.
Well,
else it'll catch
yeah, I
on
mean,
fire.
this is 2.2 kilograms, which is pretty light, but to send it out, that needs a pretty big rocket.
It would
actually.
burn up too.
Yeah. If you want to, if you want to send this up on a big rocket, you could. But one of the big objectives is we want to actually have this thing sort of floating up there for a length of time, so we can take pictures of space, pictures of the ground. So I guess if we use a rocket, this would be a one-shot, straight up, straight down sort of deal. Here, at least we have about 2 hours of flight.
Awesome.
Yes. We made this with, there's actually, I forgot to say, there was shock absorbers in here made of polyurethane on this layer, and this extruded polystyrene also acts as a good shock absorber. So it's designed to not break apart when it lands. And we also have a cut-down mechanism that's not shown here to cut away the remnants of the balloon so it doesn't tangle with our parachute. That way we're guaranteed a good descent velocity. So it will be reusable. You just have to replace the batteries and you just have to get a new balloon.
Any other questions?
When? When are we launching?
3 weeks. 3 weeks.
Yeah.
3 weeks from Goderich, right? You're going from Goderich?
Yeah, somewhere around there. We do calculations before we launch, so we actually get wind data from Environment Canada, and the idea is we can basically figure out where exactly, well, not where exactly, but a general idea of where a balloon's going to be heading. So we try to choose a spot somewhere on the shore of Lake Huron, where it'll basically send the balloon into an area that's unpopulated and away from any lakes.
Yeah. So it'll land around Alliston. That's usually our target, that area, because that's far away from
Yeah, somewhere between Fergus and Alliston.
Yeah.
So close to you.
Awesome. All right, Project Iris, everybody, give them a big hand. Thanks a lot, guys.